Mm, yeah. So, what is the difference between load flow and optimal power flow? Okay, let's. I mean, I give the choice for you people to keep answering, and then we'll see uh, whether we converge to a very convincing answer. So, the idea is to just uh, refresh our basic fundamentals. Okay. Okay. So, power flow. You want to answer something on that?
Optimal power.
So I think load flow.
Load.
I think let's do one thing. So there is a layout. So let's go for two this kind of layout. Okay. So then it's not. This is called OPF. Okay. So also let's. Okay. Anyway. So yeah, what do you want to answer in this?
So in load flows, we will have generators and loads with connected a network will be there. And we
Okay.
will use some algorithms like
So
GAS or any other method to
okay, what you are saying is generators and loads
connected
and networks
network.
will be defined. Okay.
We will use different algorithms to determine the line flow, like how much power is flowing in the
PQ,
transmission and all.
active for reactive power, voltage, current will be determined, sir.
Okay.
Which generator is how much?
Determine the just a minute. Power flows on the lines,
Yes, sir.
Yes,
Power,
both active and
yeah,
reactive
active
flows.
for reactive
current,
power,
voltage.
Active and
current,
reactive
voltage,
on the lines.
and the lines.
Okay. This is what you want to. That is the objective to determine the.
Load
Uh,
flows.
that's what is load flow, right?
Yes, sir.
Power flow. See, what do you mean by generators and loads and network will be defined? What exactly you are defining? The amount of load and amount of generation.
Yes, sir.
The contribution of each generation to any particular line or particular load. We can
Okay. So
That will be done
okay, given data. Uh,
generation.
okay, I will say uh, network data. Okay, so what is network data? So basically, nodes and links.
Yes, yes, sir.
Okay, with nodes means
Buses.
uh,
What means buses?
yeah, buses. So anyway, nodes and links with its RX parameters.
Yes,
Okay, RX parameters. Now generators, what you are saying, generator data.
generator data means we'll have that
So
megawatt
power output. Okay,
PGN, QGN.
so both P and Q output. Is it what you are saying?
No, the Q we will determine, sir. We will determine.
Okay, good. So that was a trick question to catch you, but since you know, you answered. So we only know P, we don't know Q. That is the problem with the generator. Q is unknown.
Q is
Okay.
unknown.
What else is known?
Uh, V is also unknown, sir. We will
No,
assume
V is known.
all places now.
Generator bus means
At a generator
we
bus,
define.
you define. Yeah. So PV is given. That's why it is called PV bus. Okay.
We determine
So
angles.
basically, this is known. So basically, now this is not the ultimate or whatever fundamental thing you said to determine line flow. The purpose of load flow is to determine the angles of the voltage. Okay, determine the deltas of buses. Of course, where there is no generator, there both deltas of generator buses and V and delta of load buses. So this is the first thing. If you know this data, then you can know the algorithm is for this, whatever Gauss seidel etc. That is for this. Whereas this one is a simple, once you know the V delta, you can find this one. This is the more fundamental thing. So known data is this one. So known generator data. So known load data.
PNQ.
PMQ.
Both P and Q you know.
Yes.
Yeah. P and Q. So what is unknown here?
Q and
Q and
delta.
Huh, Q and delta unknown. So this is, let's make it here. What is unknown?
Delta
V
and
and
V
V.
and delta.
Yeah. Okay, so this is the purpose of load flow. Now, one small point we need to discuss, that is the other type of bus.
Swing
The
bus.
generator data, load data we are saying. There is swing bus, right?
Yes, sir.
So what is that?
Sir, that is a reference
D delta we know in the swing bus.
Yeah.
And
the
So basically known will be,
V and delta.
yeah, V and delta, and unknown will be
P and Q.
P and Q. Now, so this one will be later. Now the question is, uh, why P is unknown?
Sir, actually, the swing bus means we will consider one of the generator bus itself. But in a network and a set of conditions,
Hmm.
in the set of conditions, the balance, the balance of that megawatt MVR may not be balanced.
Hmm.
For that, we will consider. So for that, the PQ are unknown for the assumed bus,
Hmm.
and practically all voltages are with respect to ground mass.
Yeah.
So for that sake, for mathematical implementation, we will put one generator as a swing bus
So
for
uh,
balancing load generation, sir. In that
okay.
particular
So
scenario.
basically, what he is answering is swing bus is needed so that to balance the piece. Okay. So now here you look at this generator data. Let's say there are 10 generators, each one generating some P1, P2, P3 like that. Now if you add them, you will get total generation. Now let's say there are 20 loads. You add them, you will get total load. What if they are not matching?
swing
So
bus has to
you go back
compensate.
here. So this grid is swing bus. That's why this 520, whether 550, whatever case, 180, it can be P can be plus minus whatever. We it is possible because grid is considered as a swing bus for this particular this thing. You cannot define all P's.
Yes.
If you define all P's, then addition of the P supply, addition of the P demand may not match. So in order for that, one has to be there. Of course, there are multiple swing buses also possible. That is first. Let us discuss the basics, then
I think
advance.
for a connected, like what are the buses which are connected? For all that, they will take only one as a reference swing bus.
We can take many
Yeah.
buses.
So you can define multiple like
So
that, but then again, I don't want to speak about what I don't know. So right now, I did not come as a requirement, so I did not go through the details of multiple slack buses. But I know that okay, there is a concept of multiple slack buses.
sir, even we are for modeling, we are using only one swing bus, sir. For
Okay.
all India. Not more than one. For entire India, even it will include Bangladesh, Nepal. We are using Pahalgam as of.
Okay. So now let us. How do you differentiate? What is this optimal power flow?
Sir, now in this we have only defined and we are getting quantities, sir. But
Hmm.
uh,
So
but
okay. Anyway, I mean we just speak in this language, right? So here I will say P. Here I will remove P. So now what happens? So how much power to generate? I don't know. whether this generator should generate 300. See, total demand is 500, for example, and there are two generators. What do you do? 250, 250? Need not be.
Yes.
You can run the load flow by defining 250, 250 and run a load flow. Fine. You can define 100, 400, first generator 100, second generator 400, load is this one, and still run the load flow. See, load flow you can do anyway because you have to give the P. Now, what if you give wrong P? Let's say 100 you give for first generator, 200 I give for second generator. So total generation is how much?
300.
But the load is 500.
500.
Slack bus will take it.
Yes.
So here the P will be known. Here the P will be unknown.
Yes, sir.
We are asking the algorithm itself
What?
to determine what P should be.
Yes, sir.
And of course, the same thing, determine the delta and all this. This is exactly same everything. Only thing is here you do that. But how will the algorithm know how much P to generate? So for that we need to give additionally cost data.
Even the
Cost
transmission
terms.
is there.
And also correct. See here.
Transmission
See
Transmission
now.
line.
See what if any line is overloaded?
Here we are
See,
just calculating but not checking whether the constraint is satisfying or not.
yes, so that is load flow. See, a particular line, if its capacity is only 400 kilowatt, but it is carrying 500 kilowatt, load flow will not say anything because that is a pattern of generation you are given, pattern of loads you are given. I try
We are
to.
fixing P there, that's why it is generating like this.
That's it. So if you give wrong values of P or values of P such that the any line gets overloaded, it's fine. It's overloaded. Okay, so what if any line overloaded? Uh, no action. Just
No, we are not bothering about.
yeah,
We are not
just inform the results to the user. Say you can at least you can say okay, so and so so and so
Line may
line
get
got
overloaded.
overloaded. We can print it in red color in the load flow result. But beyond that, you cannot do anything. Here, what you can do? So here,
If the constraint is not satisfied, the main generator itself controls.
no cost data of generator and
line
also
constraints.
network or we'll say line
also
capacity
line pattern.
constraints are given. Okay, so here what happens? What if line is overloaded? So what about that here? So what if any line is overloaded? Actually, it will not happen. So
During running the power flow itself, it will take
yeah,
care of that constraint also.
yeah, line overloading is taken. No, the proper way to put it is uh,
Based on network conditions,
okay.
generation dispatch will be
Yeah,
manual.
the solution will avoid line overloads. So here sometimes the solution may not exist. Okay, so if exists, will avoid line overloads. Okay, so once again, just have a look at it. So only difference from here to here is here know the generator data, that is known data for generator. V is known. Uh, Strictly speaking, we should say the magnitude of V. Okay, so the absolute value of V. V is a phasor, right? So
Yes.
here also we can say like that. But anyway, so that is getting too much something like this anyway.
Sir, that swing bus is there, no?
No.
That is
Will
not
not be
correct. That
there in OPF.
swing bus means it is PV bus.
Here, what you're saying, there won't
Only
be
slack bus, sir. There is no. I
In
think
OPF, swing bus may not be there.
in OPF no need to define swing bus. You're
Yes, sir.
saying, yeah, I think that is also correct because
we don't know which
the
will then balance the situation.
no, but then we have to define some reference for delta, right? Somewhere we have to define the reference for delta. So for that we need. See what happens is the swing bus will be assigned to one of the generator, and the generator cost also will be taken into account. See here, what is the cost of? See, you know the cost of this P.
Yes, sir.
What this P, whatever is generated, you know the cost of this. But what is the cost of this P?
We should know.
So in order to make it known, this has to be also one of the generator buses. Okay, so here swing bus, slack bus will be uh, one of the generator buses will act as slack bus or swing bus.
Swing bus,
Swing bus means PV bus, sir. I think slack
Yes.
bus don't have any other name. Only
no. PV bus, one of the generator
Huh,
bus will
so
be swing bus.
see, there is no PV bus in OPF because there is no P in OPF. We don't know P, so you cannot call PV bus. But
no.
just
In
to
case
give,
of load flow, that
uh,
swing bus and slack bus may not be same. I think.
okay,
Because swing bus
okay,
means a PV bus. Right?
okay. So you are talking about the terminology difference between.
Yes.
Okay, so this is again a question. Is swing bus and slack bus both same? Something like that. Anyway, I
Both are same.
again, as of now, I did not think about it. I just thought, okay, as long as for me both are kind of equivalent. But yeah, you can again make a distinction.
Like, yes, sir. Swing bus,
See,
slack bus, one of the
the
generation
way
bus.
to determine whether it is same or not, okay, is not if some textbook has said like that. See, you may be answering saying that definition of swing bus and definition of slack bus according to somebody told
Sir.
you or somewhere you read or something like that. Okay, so what you do is forget about that. You see what you know. So according to what I know, uh, swing bus and slack bus are
Same.
equivalent. You can replace. Now, but then why these two names are there? That means there is some logic, some reason which I don't know. So now the question is whether I should invest some time in knowing that when the situation comes. So let's say if there is some kind of exam that I am giving, then I will find out. See, if that is the case, then I don't know so many things. So as far as to the extent I know, both are equal. If required, I will find out. So like that. And if I can tell this answer, see some interview happens, and then they are asking me. If I can tell this answer, the interviewers will be more happy than if I can tell the difference between these two. This is single, this is slack bus. Maybe he mugged up and then he's telling. So the whoever is they are trying to find whether what you know, what you don't know, and then you can say okay, if required, I can find out. So like that. So that will be more convincing, right?
Yes.
So that okay. So see this the overall thing, the main this point nobody will tell that we have to see you. Okay, look at it like a what you call like a problem where you are the owner of the entire system. Okay, so what you as a system operator, what you do? So you know that so many families are living. There are 100 houses, and they morning they switch on TV, morning they switch on their water washing machine, whatever. So you survey the your population, and you get a load curve. So you have a load curve, time versus load forecast also you did. So tomorrow this is going to be my load. Now what is your response? How can I meet that load?
Based on historical
So
data.
how can you meet that load? So if you see what is the peak. So peak is let's say 400 kilowatts. Then you will see how many generators I have. Let's say you have only two generators. One generator is 100, other generator is 300. So 400 exactly matching, fine. What if you have only one generator 100, other generator also 100? The maximum you can generate is only 200, but your load forecasting saying it is 400.
I will shed the load.
So then you have to decide, okay, these houses I will switch off. This is student hostels. So this I will switch off, and this is the academic blocks. So now, okay, now that problem is solved. So this is the first one is unit commitment.
Yes.
Okay. So now I committed this many units. Now in the night you will say that your load curve is going only 80 kilowatts in the night. So if it is 80 kilowatt, you have two generators, both are 200, 200. You don't have to keep running both of them. You switch off. So after 11 p.m., switch off this. So this problem is called unit commitment. So after unit commitment, what happens then? Then your question comes in how much I should generate.
Economic dispatch.
So now I look at both the generators. First one is like a diesel generator, and the second one maybe some other fuel, maybe some kind of lesser cost fuel or whatever. So then you will say, okay, first let me use that one and this one. So people used to simply do like that, but now if you want to really do it mathematically, you do this OPF. So here you know P and Q, and you don't know what peak, and you know how much voltage you want to maintain. I want to maintain this much voltage, one per unit. Then let the program run and tell you, okay, at 10 o'clock, this much should be generated here, this much should be generated here to meet the demand. So then when you will do load flow, so what I told is unit commitment. After that, optimal power flow. Then when you need a load flow,
So for planning scenarios also we need, sir, if I am going
yeah,
to construct new transmission lines or any,
yeah,
if a new generator is commencing for
Odd
the,
addition.
yeah. So see, in a way, optimal power flow is more calculation based and intensive and all. So what if you, let's say, there's a generator. Optimal power flow is saying that let the generator capacity is 400, but it should generate only 250. Optimal power according to optimal power flow, like that.
Capacity is how much?
It's
400.
400, but the output of OPF is saying you generate only 250. Now you can ask a question. No, I want to generate 400 from there, but the optimal power flow may not be able to, solve. So then you go to load flow, set the number 400 there,
Okay.
and then run the load flow and see what happens.
Okay. Yes.
So your cost may increase, but then you may see, whether in order to make it 400 watt. See, it may happen that the generator which was saying 250, not because of the generator, because of some other line getting overloaded, this generator is having to
to reduce its
reduce its generation capacity. So now you go back to load flow and apply that 400 and then do the load flow. Then that particular line will overload. Then okay, so if this line is getting overloaded, then I will add one more line there or something like that. Then you are allowed to now generate more. So in order to increase the utilization of this generator, you may have to construct a line somewhere else. So all these things. Another thing was asked, like what is state estimation? See, your objective here is to find out, determine the details of generator process, that is V and delta. So you want to determine V and delta, right? So then why state estimation?
Sir, sir, for state estimation, sir.
So I copy this.
In which state we are operating, sir, that the delta is very critical. Delta is very much important, sir, between two buses.
Okay.
So when, means, sir, if the angle must be very less, and if the delta is increasing, sir, so we can,
Between two buses.
in states, in what state we are operating the entire system, whether it is emergency state, alert state, normal or secure state.
So if delta difference greater than
30 degrees.
some 30-degree, okay, then alert state. So
Till it is increasing emergency.
okay, or emergency state, whatever. Now, but then you're given the answer, like at a little bit not connecting to this one. See, here also you're calculating deltas, right? So the algorithms determine the delta of generator buses and V and delta of the load buses. So if you know this, then why you need state estimation? Yes, the delta. So basically, the heading here is
Sir,
importance of delta. Okay, so to that, this is agreed.
Sir, I think the objective
sir,
load flow should be the knowing the contribution of each and every generation to the
load flow is
No,
only one snapshot
no. I
of
mean,
data, sir.
contribution of each and every generator. You already know what is the
losses.
no. You know already what is the
We know the losses means generation and load. We can separate, subtract, and we know the losses.
Sir,
But if we want
This-
to
this-
know the losses, which means losses at 50 kilowatt is happening, but
Okay.
contribution of each generator, how much contribution is doing for 50 kilowatt, that should be the objective
So
of
so basically,
load.
what you are talking about is called loss allocation. Okay. So now, okay. Let me just let's say let
Because finding the
in a system
V and angle.
let total generation is equal to, let's say, 1150 kilowatt. Let total load equal to 1100 kilowatt. Okay. So now the question what you are saying is which generator is sharing the extra 50 kilowatt? Is this what you want to ask?
That is the objective to find the load flow.
No,
Because
but the load flow objective is not that. The load flow objective
PMU
only to determine the.
PMU can define voltage angle by easily. There is no need to.
So now you're
uh,
introducing
know the
PMU. We'll come back to that. Duplicate slide. Let's before I forget. So uh, see phasor.
Measuring.
So just a minute. So calculation, estimation, measurement. Okay. So these three things are important. So delta angles. I just want to be a little bit more specific, so I'm just adding this thing. So for calculation, you can have load flow or optimal power flow. For estimation, you have state estimation. For measurement, you have PMU. So if some unknown value is there,
Sir, I got the point, sir. For state
so no, you hold that point. If some unknown quantity is there, how much bank balance I have? There are three things. I can calculate my bank balance. How I can calculate? Okay, I can take in notes. Today, these are my this much salary I got, this much I purchased, this much shopping, this much, and then I can calculate it at my house. That is calculation. I can estimate. Okay, today is 15th, so I got first salary. Then I have this many EMIs. That EMIs might have already cut. So maybe approximately maybe in my bank maybe 30,000 maybe there or 50,000 maybe. You can estimate. You can measure. Just go online, do a log into your bank account and do that. So, same way, what are the angles in your system? So, using load flow, you are calculating the deltas. Using state estimation, see, actually, there is a measurement also is there, right? See, state estimation on what you are doing on the measured data. But the problem is you are measuring using CTs and PTs. You can only measure the voltage magnitude. You cannot measure the phase of the voltage. So angles you cannot measure.
we keep on seeing the same.
So you are measuring the voltages and you don't know angles. So that's why you are estimating the angles. That's why it's called state estimation. In state estimation, using the measurements of voltage, you are measuring the angles. Now, what is directly measuring the angle itself? How can you measure delta? Because delta is always reference, right?
It is a relative.
It is a relative quantity. Delta is not like, delta here is some absolute value. It is related to some other location. Okay, so then you have to define some place delta.
Yes.
With respect to that, you have to define what is delta
this one
here. Now the problem is in one cycle. So what is in 50 hertz? If it is take 50 hertz. So let's make a new slide. So maybe this one. So this is like a sine wave, right?
Yes.
So what is the time period?
20 milliseconds.
Yeah. So if frequency is 50 hertz, then your time period will be 20 milliseconds. And should be small. So this 20 millisecond is pertaining to 20 millisecond pertaining to 360 degrees, right?
One second.
If you want to talk about the phase of the phasor will be 360 degrees, right? So therefore, in 1 millisecond, you will cross 18 degrees.
Yes.
So now to measure the, so let's say you have a network. Okay, so there is a network like this. So this is a power system network. So in a particular geographical region, so power is being distributed somewhere like this. So now at this location, so let's say at location A, and now location A to location B, let's say the distance is 500 kilometers. It is possible, right? We can have a
Yes.
long distance this thing. Now, if your accuracy of timing is 1 millisecond, and if you want to measure the angle, so how to measure the angle? So if you have two waveforms, okay, so this is one waveform, uh, another waveform. So let's give it a different color. Now you want to, let's say this is VA, and let's say this is VB. So what you're doing basically is you're taking the values like this in a tabular form. Time V small va, that means instantaneous value with respect to time. Okay? So I will even make it what you call italics. Okay, so in a keyboard, I and U are neighbors. So when I press Control I, Control U also got pressed. So it is underline also came. So now here, let's say time 1, 2, 3, 4, 5. So what is the unit of this time?
Thanks, sir.
Yeah. So let's say it can be even 1 millisecond one reading. Let's say. So now what happens at the time VA equal to let's say VA equal to 0. So at the time VB may be, so if you again take it as a per unit. See here VA is 0. So VB may be at maximum or something like that, right? So you will get this data. Okay? So maybe 1.0 something like this. So you analyze all this data and then try to map on the same time, and then say that okay, the peak See, wherever you are crossing zero, that can be the starting for that. And then, so the zero of this VA and the zero, let's say it achieves zero here, VB achieves zero here. So now you will see the timestamp here and timestamp here. This zero here, this zero here. The gap between two
Difference is
zeros
three.
will be the phase difference. For this technology to work, what is the problem? If your time, see, two 500 kilometers apart, if your time is not synchronized, let's say I will call you at 4 p.m., but your watch is 5 minutes fast and my watch is 2 minutes slow. Then what is 4 p.m.? We don't know. So both times have to be synchronized. Even if there is a 1 millisecond gap in the synchronization, 18 degrees error will come. So what is the accuracy they maintain for PMUs?
No, as of now, they're taking sample for 40 milliseconds, sir.
Sample can be taken 40
40.
millisecond, but
They are uploading
that is what you are saying is
GPS,
the
GPS
what you are saying is the sampling time of measuring the phasor. But
GPS,
for that particular measurement, there is a timestamp, right?
GPS.
So what is the time synchronization? I mean accuracy of time synchronization for PMU. So for example, if it is zero point 0.1 millisecond or 100 microseconds, then your error will be 1.8 degrees, which is still not may not be acceptable. Then if you have 10 microseconds of time difference, then 0.18 degree may be acceptable. So even though you are taking samples at 40 millisecond, the internal clock of the PMU in city A and the internal clock of PMU at city B has to be synchronized with accuracy of
at least
Less than
less than
10
microseconds.
microseconds.
Okay, I said 500 kilometers difference, right? Now, what is the speed of light?
3 into 10
10
power
power
8 meters
So
per second.
3 into 10 to the power of 8 meters per second, right?
That
So 3,
multiplied by this
1,
is
2, 3, 4, 5, 6, 7, 8. So I'll remove 3. So now this will be kilometers per second.
kilometer per
Okay.
3 into 10 power 5.
Now, what is my 500 kilometers is my distance, right?
And
So if I divide this thing, so I don't know what I calculated. Just a minute. This is speed of light in kilometers per second. Huh. So how much time it takes for light to travel from A to B?
meters per
500
second.
kilometers. How much time it will take?
So
So
distance
this is
by
time in seconds.
Hmm.
So 1.6 millisecond it takes for the light to travel between these two. That means for the information to travel also it will take 1.6 milliseconds. But then the problem is for 1.6 milliseconds, again there is this 18 degrees. So,
Mm,
so if you say at this instant in CTA time is T1, at what instant you should say the time is T1 in B. So again the problem is time itself is relative. There is no absolute time. So they need to, while designing all this, GPS and all this thing, they need to consider that also. So all the things happens in the background, and finally,
that's why in GPS they are taking that fourth satellite to correct this time offset errors.
so that is because of the again the relativity problem. Okay, so again, I don't know much about it. So that's why calculation, estimation, and measurement. So cheapest is calculation. You just calculate the phase angles by defining your network and all. But then if you have SCADA system, what SCADA will do, it has a, now SCADA data 2 minutes late also no problem, because you're only measuring the voltage magnitude,
Yes.
and using that power flow equations you are estimating the delta. So and if that estimated delta is within, so now the question is, if life is okay with this state estimation, why you go for PMU?
The dynamics are not being addressed with the state estimation. Means that
that is estimate.
any change of frequency is
Yeah.
there.
So usually they use this terminology, this state estimation is like X-ray, and
This is like
PMU is like a CT scan.
Yes.
So in CT scan you get more details compared to in X-ray. What you miss, that you will not miss in CT scan. So that way, anyway, so that is the other discussion. So now this is another discussion again, loss allocation. See, the allocating that loss is not done by load flow or anything. That you have to separately calculate.
Metering that.
Yeah, using meter data, whatever. But still, anyway, so we are doing that, right? Estimation.
State estimation. Yes.
So I think that point is covered already. So here OPF in this loss. Okay, so I think this point I will delete here. Yes, it is. Yeah. Anyway, so I think so. Just I mean, these are the things you should be aware so that you can effectively answer. You know what is the this thing. See, again, the concern is, if you go outside and then if somebody asks this question, so they will say, okay, where you did your PhD from? So that is the thing. So anyway, to protect from that, we are worried. So so that way. Okay, where is the issue?